All right, so hello again. It's my third video of the day, so getting a little tired. That's okay. So in this video, I'm going to give you a quick sort of overview and walkthrough about how to use list comprehensions in Python. So this is a special Python syntax for doing mapping and filtering operations, similar to what we talked about in the previous video. It's basically a shorthand way of writing the loops that do mapping and filtering work, and it's sort of, it can be a little bit slick, but it's also a little bit confusing, so I tend to put it off to the end. All right, let's get going. So here's a standard mapping operation here's our mapping operation that we talked about in the previous video. So again, in this case, we're going to take our initial list, our numbers. We're going to then create our new list of what's going to be the transformed set of values, loop through our list, create our transformed value, and then append that to our new squares thing. And this was sort of our structure that we were using over and over again. The only things that ended up really changing were what our transformation operation ended up being, and then what the loop is that we end, and then what's the loop ends that we end up doing. So what a list comprehension is, it's a shortcut for doing all of this work. And the way it works is as follows. So in the end, I know that squares is going to be equal to something. It's going to be equal to a list. So what I'm going to do is I'm going to take this brackets, and I'm going to instead put them sort of around all of the code that I want to write. So that I'm actually going to end up putting sort of all that together. Then what I'm going to do is I'm going to be like, well, this transformed thing is already sort of redundant. Like, really, I'm just going to be taking that n squared, and that's what I'm going to be appending right here. So we're going to sort of squeeze that part as well. So again, I'm just trying to like make things go, so I'm just trying to reduce space. And then because I know that I'm defining things squares, I don't have to call it squares.append again. I know that I'm going to be doing that automatically. So what I'm then going to do is I'm going to take this expression, and instead of having it go at the sort of end of my loop here, right, so I see I'm running out of space, I'm going to take that expression and I'm going to put it actually at the beginning of my loop. I'm going to get rid of the closing quote, and that gives us a list comprehension. So this is doing the exact same work. I haven't typed anything new. I just moved some things around and deleted a bunch of extraneous like append calls and repetition of the variable names. So that when I do this work, it produces the exact same result. The way that ends up getting read is I'm basically saying that my squares is going to be a list, because it's got brackets on the end, and in that list, each value is going to be n times n, and there's going to be one value for every n, so it's going to be n times n for every n in my list of numbers. So it almost reads through that this is a list whose values are n times n for each n in the numbers, which it feels a little bit weird to talk about, but if you say it sort of slowly, right, it's going to be a list whose each value is going to be this number multiplied by itself for every number in that list. That kind of almost actually reads almost English-like, which is part of what makes this a little bit smooth and easier to write. Okay, so what this sort of looks like in general. So this is an example of a list comprehension. And I said this is a Pythonic syntax for doing mapping and filtering, and that's a mapping example particularly. So the syntax we're going to use here is that we're going to specify the name of our new list, right? What's the thing we're trying to create? In this case, squares. We're then going to put a set of brackets around the end. And I actually said this right. So we're going to start with our brackets around the end. We're then going to put the loop itself, right? Not necessarily all the content of the loop, but just the for blank in blank part of our code, and that's going to go inside of the brackets. And then we're going to take the transformed expression. What's the value I want to create for every element in that loop? And we're going to put that before the loop inside those brackets. So what we're end up doing is we're end up taking this fairly long sort of standard block of code, and we're transforming it into a smaller, in theory more easily to read, or at least quicker to type kinds of operation. So what this ends up looking like is we get our new list. It's going to be equal to an expression for each variable in that sequence, and then this expression should in theory be based on that loop variable. It doesn't have to be, really. This could be anything we want, right? So I might say, like, we could say we want this to be a number 3 for every n in numbers, in which case I'm going to get ourselves a list of 3s. We could literally just say, give me every number for itself, and then we just get our list repeated back. So we were able to do a lot of sort of looping kinds of work to be able to reproduce this just by modifying what we want that expression to be, what we want to do with this value for every element. So again, it's just this mapping operation. What transformation, what do we want to do for every element in that list? And we put what we want to produce in front of the loop. And that's the sort of the list comprehension process. So that's a mapping operation. We can also do filtering operations inside of our list comprehensions. So the way that we're going to do that, it's going to look fairly similar, in fact. We're going to do sort of the same kind of results. So we're gonna start with our evens, because that's like the list I'm gonna do on the same even example that I used in the previous lecture. So we're gonna start with our evens list. And so again, we're gonna basically say, let's take our empty list we're creating, we're gonna put those brackets on either side of my code. We're then gonna take the for loop itself, we're gonna put the for loop directly in there. We're then gonna take the expression that's getting appended to my list in the end, and put my n right there in front of the for loop, just like we're doing mapping, right? So effectively, this step, we're now doing a mapping. We're taking every number, we're mapping it directly to itself. But in order to include the filtering step, we're going to add in the if statement by literally moving that line of code up next to the for loop, basically deleting the bracket that's missing from my slide anyway, in order to then, and deleting the bracket at the end, to say that we're going to, in order to move that condition sort of to the end of my comprehension. So the way to get this read is we're going to say that my even numbers are going to be equal to a number for every number in those numbers if that number mod 2 is equal to 0. So if that number is even, it gets included in my list. And so then overall, this is going to produce the same set of even numbers that we've done previously in terms of how things work. So the basic idea here is, again, that we are taking effectively a loop that we've already written. We've already written this mapping and filtering kinds of loops, but we're just effectively deleting a bunch of extraneous parts, like we're deleting the duplicated variable name, we're deleting the append statement, we're getting rid of some colons, and we're moving the expression to the beginning, and then otherwise sort of combining it, smashing it all together into one line to produce this one line statement that's going to basically specify exactly what we want to do, how we want to do this mapping and filtering work. All right, so I want to clarify that we can actually go through and make list comprehensions fairly complex and can actually represent fairly complex loops working with actually multiple arrays or even nested arrays if we want to. So here's an example where I've got a list of entrees, like main courses for a meal, and then a list of side dishes. And the idea is that maybe I want to take these loops, and I'm going to use a nested looping structure to let's try to come up with every combination of entree and sides, but I want to make sure that I'm going to filter out so I'm going to do a sort of transforming work where I want to say transform my list, my sort of two lists into a single list, a mapping-ish kind of work, but I want to filter out any values so I don't end up having entrees and sides being the same. So there shouldn't be veggies as the entree and veggies as a side because that feels redundant. So the way I would do this is, again, I would say let's make my new empty list that's going to contain all my sort of resulting values. I would then say go through all the entrees, right? Go through chicken, fish, and veggies, and then I want to compare that with all the possible sides. So for every entree, so for the chicken, look at all the different side options. If those two things are different, then I can then say make a combination meal, entree and side, and add that to my overall list of meals. If I then do this work, it does that loop, and it gives me chicken with potato, chicken with veggie, fish with potato, fish with veggies, veggies with potatoes, but then doesn't give me veggie with veggies. That part gets filtered out at the end. So we can take this kind of work and convert this into a list comprehension, which I have down here at the bottom commented out, but I'll sort of walk through the transformation so you can see how this works. So again, we know that our thing is going to be called meals. I'm going to take my brackets. I'm going to start off with those. The thing that I'm appending to my meals thing, right, the expression inside of append is this entree plus side. So I'm going to put that first. That's the first thing we're dealing with. I then have this series of loops, right? I have these loops, if. So I can actually just take that code, I'm going to paste it directly inside of here, and then start deleting the white space. And then we're done. That's the whole thing. So I'm going to say that my meals are going to be the entree and side for every entree and entrees, and then for every side and side. So I'm doing this nested loop by including a nested loop inside my comprehension that doesn't break anything. And then I've got that if statement as well, that extra filtering step that also occurs here down at the end. And again, this produces the exact same result. So the idea here is that we can actually do fairly complex things with comprehensions. We don't necessarily want to keep them too complex. If you end up finding yourself doing a lot of nested loops, or it's getting like the point where it's getting so long that you can't even read it because it runs off the side of the screen, that might be a good suggestion that maybe you don't want to use a comprehension for that. That's why we want to go back and use a standard list. But the idea is we can actually mix and match some more or less complex things depending on what kinds of transformations and what kinds of filtering we're trying to do along the way. Great. So overall, list comprehensions are considered a more Pythonic. They're a more sort of standard, normal way of writing Python code. They only exist in the Python language. No other language supports list comprehension syntax in this particular way, which is part of why I tend to not push it off to the end, because only Python programming does this. Every other programming system you'll ever work with doesn't do anything like this. Though they still use mapping and filtering, they just do it in different ways. So I don't encourage using list comprehensions early on. In fact, I actually sort of say that you can't use them. You should just use standard loops in order to understand how looping works. But now you're starting to get the hang of how to write loops, and we're trying to write things that are more complex, using this more standard Pythonic sort of normal-ish way of writing Python loops is going to tend to make your code, it'll make it a little bit more concise, which is not necessarily a bad thing or a good thing, but it'll help make it sort of more standard, more the kinds of things you're going to encounter as you want to write code or work with other people's code as well. So in general, you don't need them. They're not required. You can just use standard loops. And if your loops end up getting complex, stick with a normal loop, particularly if you end up finding you need to do more than just append to a value. So if you're not producing a new list of appended things, don't use list comprehension, right? List comprehensions are only for doing mapping with some filtering operations associated with them. That's the only time you want to use them. So if you're just trying to loop through and print everything, that's not what a comprehension is for. So, if you need to do more than one work in a line, don't use them. But if you're just doing something simple, a basic mapping, a basic filtering, or basic mapping and filtering, list comprehensions are probably the way to go to help keep your code sort of more. That's sort of the standard way. That's the way that we end up writing code.